PUTNAM 2016 B6 double summation problem. And in this problem it will be easier if you try to introduce an integral in some ways, but for that I will share the motivation why. And this is a B6 and in PUTNAM A6 and B6 are supposedly the most hard problems, but it's not too hard as well as we might expect it to be. Okay, so over here there is somehow a Taylor series expansion looking thing for ln of 1 plus x, kind of, yeah. There's a k over here, minus 1 to the power k minus 1, but there isn't really, there's 1 to the power n over here, but we can also get a x to the power n using this expression, because if we have x to the power k 2 to the power n dx and its integral from 0 to 1, yeah, this will be the same expression that's here over here. And now this can be written as x to the power 2 to the power n to the power k, and if we bring this expression over here, we have x to the power n as well, yeah. Now, and so this problem will be somehow simpler using this method. Now let's solve it. Sum from k equals to 1 to infinity minus 1 to the power k minus 1 by k, sum from n equals to 0 to infinity, and now this is integral from 0 to 1 of x to the power k 2 to the power n dx, yeah, because its integral is x to the power k 2 to the power n plus 1 by k 2 to the power n plus 1, and from 0 to 1 the same thing will be there. Now let's interest in the Summation integrals. You do need to take care of conversions, yeah, but yeah, that will not be a problem, so that's why let's do it. And let's try to write first of the n and then of k. It doesn't matter, we can interchange. And wait, the limits are from 1 from 0 from 1 to fine 1 to infinity, yeah. And now this is minus 1 to the power k minus 1 by k, and this is x to the power n to the power k dx. And now I already shared that this is actually a Taylor series for log 1 plus x, yeah. That's why sum from n equals to 0 to infinity, this is ln of 1 plus x to the power 2 to the power n dx. Okay, now how do we deal with this? First of all, note that this is actually the log of the product from n equals to 0 to infinity of 1 plus x to the power 2 to the power n, yeah. Now after this, this is also just like the series expansion of Taylor series. This product is also a well-known product, like it's basically known to most of the mathematical community who are solving problems. Like this product and the previous Taylor series, these are some special, well-known and popular ideas, yeah. And the special thing about this product actually is, let me see here, if you don't know, if you know, you can skip this part. The special thing about this product is to the power n. So the product is 1 plus x to the power 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, and it goes on, yeah. And let me just first of all show you by multiplying first two expressions. What do we get if we take these two? If we multiply just these two, we get 1 plus x, yeah, multiplied 1 plus x with 1, and then x square, we get x square plus x cube. You see, we get this expression. There's just like a continuous increase of power 1 by 1. Now let's include this 1 by x to the power 4, and let's see what do we get. Okay, so first of all, when you multiply by 1, we get the same expression, 1 plus x square plus x cube. Now when you multiply by x to the power 4, the first one gives x to the power 4, the second one gives x to the power 5, the third one gives x to the power 6, and the last one gives x to the power 7, yeah. And now similarly, let us multiply by 1 plus x to the power 8. and yeah, we get the similar expression. Basically we get the sum from n equals to 0 to next is 16, yeah, so after 15 we get this sum. And if it continues, we actually get it when this product is going from n equals to 0 to up to infinity. We get this thing, sum from n equals to 0 to infinity of x to the power n. You get the idea, yeah? Okay, so that means we have integral from 0 to infinity ln of, now this is a sum from n equals to 0 to infinity of x to the power n. Now since the values of x are first from 0 to 1, this will converge. We can use the infinite geometric series, and that will be ln of a by 1 minus r. Yeah. And now if you use King's rule, you can write this as integral from 0 to 1 of ln of 1 by x dx. If we don't know about King's rule, basically integral from a to b of fx dx, this is equal to integral from a to b of f of a plus b minus x dx. This is the King's rule. And so I substituted x by 1 minus x and I got this expression. Now this is just minus integral from 0 to 1 of ln of x dx. We know that its integral, it's just x ln of x minus x, yeah, going from 0 to 1. Okay, and now minus 8 1 ln of 1 is 0, and this is minus 1, and this minus now becomes plus. Now over here, limit x tends to 0 of x ln of x. You can find this by L'Hopital's rule, and you get this to be 0. Yeah, basically it looks like 0 times infinity, but if you use limit, you get 0 minus 0. So the answer is 1. A really nice answer. Yeah, the unity. So the answer is 1. And this problem, once we figured out that how to continue the power series over here, how to introduce x to the power k times 2 to the power n, other things were not too hard. So only the first step was somehow kind of to be thought of properly. Others, this is well known. This one is also well known to most of the people, and yeah, this was pretty easy thing. But yeah, I was just wondering how did it get into B6, because A6 and B6 are supposedly the most hard problems, but it's kind of for B2, B3 or something like that. Yeah. Anyways, hope you guys enjoyed the solution, and keep problem solving. Thanks for watching, and look forward to seeing you in the upcoming videos too.